Good day once again, everyone, and we are back together just looking at calculus, in this case, optimization in particular. So, if you haven't subscribed, please just make sure you're part of the family. And of course, you can join in that family as a member, all right, and benefit from some valuable perks. I know that you guys have been waiting for this optimization part. Okay, so let's jump right into it and make sure that you've got the solution for it. Okay, so they give us a wire which is 12 meters long. Okay, so here we are. I'm going to try and draw that. Okay, so the length of our wire is 12 meters. Okay, so they say they cut into two pieces, right? They say the one piece, so we're going to cut this wire into two pieces. Now, I want you to note in this case, they did not say equal pieces. They just said they cut it into two pieces. So that's very important, ladies and gents. Okay, so they say one part is bent to form an equilateral triangle. Now remember, an equilateral triangle is one that, has equal sides. So suppose, let's say we cut it there, all right, and now they say the side, so we take this portion and we're going to form a triangle, an equilateral triangle using that side. Okay, right, and they say a side of the triangle has a length of 2x. So if it's an equilateral triangle, which means that each side would therefore have 2x each, right? Now, so which means, ladies and gents, this part that we cut out, okay, would actually be 2x plus 2x plus 2x, which is actually 6x. All right, so that means that this part that we cut out to form the triangle would actually be 6x, right? So the first question, they say write down the length of a side of the square. Okay, I didn't see the part about the square. They say one part is bent to form an equilateral triangle and the other a square. All right, so which means the rest of this other part, which I'm trying to just show here. So with this other part here, we actually formed a square, right? All right, so the red part, we actually formed a square using that. Okay, right. So now they said, so we know what would now be left would be 12 minus 6x. Okay, so this would be the red part here. All right, so we took 6x out, then we left with 12 minus 6x. Okay, right, now they say to us, write down the length of a side of a square, right, in terms of x. Okay, now we took 12 minus 6x and we bent it into 4 equal parts, right? So we want to know how much a side would be. So obviously this would be one side of that square. So which means it's divided by 4. I'm sure you're following, ladies and gents. So we are simply going to say, all right, so each side, I'm just going to say the length of each side will be 12 minus 6x, right, which is that entire side, divided by 4, right, because we divided that into 4 equal parts. All right, so 12 over 4, that would give us 3. Okay, and 6 divided by 4, in this case, that would give us 1.5x. So which means that the length of each side of the triangle, of the square rather, would be 3 minus 1.5x. So you can say 3 minus 3 over 2 x. Okay, right, now the next question, they say to us, so for 9.2, so they say to us, if this square is now used to as the base Okay, so that square that we're going to use now as the base. Now, we remember each part is 3 minus 1.5x. Okay, 3 minus 1.5x. Okay, right, and they say to us is now used as the base of a rectangular prism, right, with a height of 4x. Okay, determine the maximum volume of the rectangular prism. Now remember, when we talk about a rectangular prism, so we're going to take the base of that, okay, and what a rectangular prism actually looks like would be something like this. Okay, of course, we're going to try and join the other two sides. Okay, so I know I didn't write it or draw it nicely, okay, but I hope that you getting the gist of it. Okay, so I'm trying to draw this such that you are able to see it. So this is what our rectangular prism would actually somewhat look like. Okay, right, so we know the base. Okay, so I'm going to try and shade that base there. Okay, so there's our base there. They did say that the height should be 4x, right? And remember, our base is made out of that, square there, with each side being 3 minus 1.4. So in this case, I know this guy is 3 minus 1.5x, and of course the length would be 3 minus 1.5x there. Right, now we're trying to find the volume of this guy, and obviously when we find the volume, okay, we're going to find the volume in terms of x. This is going to be length multiplied by the breadth multiplied by the height. Okay, so we know that this is going to be length times breadth. In this case, that's 3 minus 1.5x times another 3 minus 1.5x, because the length and the breadth are the same. So I'm just going to say squared multiplied by 4x. Okay, right. So we want to actually maximize that volume over there. Okay, so perhaps let's write this as 3 over 2. I think it just makes things so much easier for us. Okay, remember 1.5 and 3 over 2 are exactly the same thing. Right, so this is going to be, so that's going to be 9. Okay, right, and then we say 3 multiplied by 3 over 2. That would be 9 over 2, right? Square multiplied by 2 rather. So that would be 9 over 2 times 2. That would become 9, right? So that would be minus 9x. Okay, right? So remember, when we are repeating brackets, right, so that I don't confuse you. So we've got 3 minus 3 over 2x and 3 minus 3 over 2 x, right? So using our FOIL method, this times that would give us 9. Okay, this multiplied by that, 3 times 3 over 2 will give us minus 9 over 2x, but you'll have another minus 9 over 2x, and this is plus 9 over 4x squared, right? And of course, when you add these two, they should give you 9. So that's where I was getting this 9 minus 9x plus 9 over 4x squared. Okay, but remember, all of this is multiplied by 4x. Okay, right. So that's the volume in terms of x. So let's multiply that into there, right? And what I'm going to do is multiply with this one first so that I put it as a nice quadratic equation, right? So that will give us 9x squared, right? 9 over 4 times 4, 9x cubed rather, because that's x times x squared, right? And then we go to this one. So we're going to say 9 times 4. So that's going to be 36. So that's minus 36 x squared, right? So x times x will be x squared. 9 times 4 is actually 36. All right, so the next one, that's 4x times 9. That should give us again plus 36x. All right, so I hope that you are able to follow. Okay, let me just put this away because we're explaining something there. All right, so in this case, now we want to maximize the volume, isn't it? Okay, so we want the values of x that will be able to optimize this volume. So all we simply do is say, well, take the derivative and make it equal to 0. Okay, so let's take that derivative there, right? So that's going to be, again, jump down. So 9 times 3, and 9 times 3 is 27. 27 x squared, right? Again, jump down. 36 multiplied by 2. Okay, so that would give us minus 72x. Okay, and this is plus 36. Okay, so that's 36, and this is equal to 0. All right. In this case, all of these are factors of 9, I believe. Yeah. So we can divide all of that by 9. So that would give me 27 divided by 3. This would be 3x squared, right? If we divide that by 9. Okay. And 72 divided by 9. So that would give us, I believe that would be 8, right? Okay, so that would give us 8. All right, let's just make sure of that. 72 divided by 9. Yep, that does give us 8. So that's minus 8x plus. So again, 36 divided by 9. That should give us 4. All right, if you wanted to, you could use the quadratic formula, right? So let's see, factors of 3 and 4 such that when I add them, I get 8. Can we get that? So 3 and 1, let's see, if we say 2 and 2, okay, so that is 3 times 2. Yep, I think we get that. 3 times 2, that gives us 6. 2 times 1, that gives us 2. And if we add those two, we definitely do get 8. So that means that our first bracket should be equal to 3x, and so that becomes our first bracket, that becomes our second bracket, right? So that becomes 3x and 2, and this becomes x and 2 as well. All right, so we know that our signs would be the same, and it would be that negative sign there. All right, so in this case, x is equal to, let's say, 2 over 3, okay, or x is equal to 2. Now, in this case, what we want to do, ladies and gents, is we want to make sure that we maximize, they had actually said determine the maximum volume, right? So in this case, we've got two values that we get, okay? So we want to know which one would actually be the maximum value and which one would be the minimum value of this particular curve, right? So we want to find out in this case which one maximizes. So, right, so in order to maximize in this case, we want to take v double dash, okay, of, we can check them. right? So we can take this one and check, in this case, is it going to give me a maximum value or is it going to give me a minimum? Or in fact, you know what, let's even do this. Let's take each value, right, and actually substitute back into the original equation, right? So if I take, so for instance, if I take 2 over 3, so if I say v of 2 over 3, right, this would be 9x cubed. So that's 9 times 2 over 3 cubed. Okay. So that's minus 36x squared plus 36x. Okay, so that's minus 36, 2 over 3 squared. Okay. Plus 36x. That's 2 over 3, right? Okay, so we'll check between those two values which one actually gives us the maximum. Okay, and again, v of 2, so that would be 9 times 2 cubed minus 36 times 2 squared plus 36 times 2. All right, let's find out. So I'm going to take that value. So that's 2 cubed. Okay, so in this case, right, so all right, so we take this value here. We're going to actually take the cube of that, so minus, so that's minus 36 times 2 squared. Okay, and this is plus 36 times 2. All right. I get 0 with that value. So definitely does look like the one that we'll end up going with. Okay, right. You can see that value gives us 0 at the end. And so it's probably going to be when x is actually 2 over 3, right? So I'm just going to cheat that a little bit and say 2 over 3. And I'm going to have 2 over 3 over there. And I'm going to have 2 over 3. All right, so I get a value of 10.67. So that would be my maximum volume, right? So that so it means that this value here is not applicable. So which means that x would actually be equal to 2 over 3 units. Okay. Right, and that is how the cookie crumbles, right? I hope that you understood that, ladies and gents. And for those of you that are still struggling with this section a little bit, please just have a look at, some of the videos that I've made on this particular section. All right, but otherwise, I hope, you really enjoyed, just the detailed, lessons that I've been given in this particular section and other sections as well. And I want to wish you all the best for those of you that are writing either tomorrow or anywhere in the future. Otherwise, from me for now, I'll see you guys next time. Sharp, sharp.